So today we're talking about Jupyter extensions, specifically those that will apply to JupyterLab and to Jupyter Notebook version 7 and higher. The talk is designed as a tutorial. Basically, I'm going to do the tutorial in front of you. At the end, I'll explain the code and so forth. At the end, there'll be links to the repository that contains this code with documentation, and you can go home and code the tutorials yourself. It usually takes a little longer than a half hour, so I'm going to skip a few things. I'll mention when I'm skipping. Everything I'll focus on the tutorial itself, and what I'll be skipping is some more of the big picture stuff. Prerequisites, I assume everyone is familiar with Jupyter and knows how to code classes. A little bit about Bloomberg, the company I work for. This is what we do. Data, analytics, APIs for the financial community. A little bit about the data that we handle. We have some 70 million securities on our system with about 40,000 different fields. So that's about, trillions of pieces of data. We handle up to 400 billion field updates, market data, every day. And we publish over 5,000 news stories a day. This just shows market growth from 2008. A couple of years ago, we hit 300 billion messages a day, and now we're upwards of 400 billion messages a day. We have a website that talks about data science at Bloomberg. Our marketing guy asked me not to mention the specific URL because it might change, but if you do a web search, data science at Bloomberg, you should be able to find information about what we do regarding data science. We have some 21,000 employees around the world. About 40% more than 40% of our staff are software engineers. We're very engineering centric. And about a little less than half of our engineers use Python on a daily basis. And we contribute to open source and sponsor open source regularly. You can skip about me. You can read my bio if you're interested. For those who are very familiar with JupyterLab or Jupyter Notebooks, but maybe not JupyterLab, I'm going to give a quick tour of JupyterLab. This is JupyterLab. This is what we call the main area right here. This particular tab here in the main area is what we call the launcher. I can launch a notebook from here. I could launch a terminal, launch a Markdown file or a Python file for editing. Over here we have what we call the left side panel. Over here there's a right side panel. There's some debugging commands over here. The side panels can be closed to enlarge the main area. This particular left side panel is called the command palette. We'll be using that in the tutorial. There's another side panel here that's of interest. This is the file browser. You can click on a file, open up a notebook, open up a Python file or another Python file. These tabs can be dragged around so you can put the files side by side to compare them. Close the side panel again so you get a little more room. So that is JupyterLab. Now our tutorial, what we're going to do for our tutorial, we're going to add a command here in the command palette, hello world. And over here in the launcher, we'll add the same command. And when you click on it, you'll get hello world from PyData. The last step of the tutorial, we'll create our own side panel over here with different buttons where we can click on them and we can say hello world in different languages. Now, why would you want to do that? Well, the idea is this. Once you understand JupyterLab and the Jupyter extension framework and you can get your own code, get your hello world in there, you can code it to do anything you want. So just to give you some examples, here I have a side panel where I have a search field. And I can put, for example, a ticker symbol of a stock in that search field. The extension goes off, gets the data for the stock. I can click on candle chart, and I get a visual display of the data in a candlestick pattern. MACD chart does a MACD analysis on the data and provides a visualization again. Now, just to give you some ideas where you can go with these extensions. So in that extension, we did a data fetch, we did an analysis, and we did visualization. You can imagine also you might write an extension to do machine learning and to allow the user to select between different machine learning models. You could create an extension, for example, that allows people to collaborate and contribute data or manage very large data sets and annotate them and so forth. So that's just to give you some ideas of where you can go with these extensions. Now, before we start the tutorial, a couple of vocabulary words. If you hear the term NB extension, it stands for notebook extension. This is the old classic Jupyter notebook extension. These are being deprecated. We're not talking about these today. We're going to talk about lab extensions that apply to JupyterLab and also to apply to notebook version 7 and higher. At Lumino and at JupyterLab are NPM package scopes of TypeScript and JavaScript packages, and we'll be using those. Plugin is the class that provides the basic extension functionality, and now we can define an extension as a package that you can build and distribute that contains one or more plugins. A token that we'll see, it's an instance of the Lumino token class. This is a service or an identifier for a service that we can use within our plugin. The Jupyter front-end application has a property called commands. This is a command registry. It's basically a mapping between a command name, a command identifier, and a function. And by putting functions into the command registry this way, they can be accessed anywhere within JupyterLab. Widgets are basically everything on the screen. They're all derived from the @Lumino widget class, and JLPM stands for the JupyterLab Packaging Manager. That's Jupyter's own version of the Yarn Packaging Manager. So very quickly, just to go through the steps of the tutorial. Step 0, we're going to use a template to create a basic do-nothing extension. Then we're going to modify the extension to add a command to the command registry. We'll see how we can execute that command from the command palette. We'll modify the command to place a widget on the screen. We'll see how we can style the widget. And then we'll see how we can execute the command from somewhere else in JupyterLab. Specifically, we'll do the launcher, but you could do it from the menu or from various icons on the screen. And then we'll see how you can execute a command with arguments so you can make it behave differently. Maybe you want it to behave differently depending where it was executed from, or maybe you want users to have preferences as to how they want your extension to behave. And finally, we'll create our own sidebar widget where we can execute our command with various options. So to start, we want to create a virtual environment. We'll use con to create. We want to name our environment JLX for JupyterLab extension. We want to override channels with strict channel priority, and we're going to use channel con to forge with no defaults so that we don't want to fall back to anything else if con to forge doesn't have our package. We're going to install JupyterLab Forward, Node.js 18, Git, Copier 7, and Jinja 2 time. When you run that, your screen will look something like this. It's going to list all the packages that it's going to install to the virtual environment. And when it's done listing the packages, it'll ask you, do you want to proceed? And then you'll get a progress bar. And when it's all done, it'll tell you to run con to activate JLX to activate your virtual environment. Now that we have a virtual environment, now we can use the templating tool, Copier, which is similar to Cookie Cutter or Yeoman or other templating tools, to generate our extension. So we're going to call Copier copy. We're going to get the extension from GitHub, JupyterLab extension template, and we're going to name our extension PyDJLX, standing for PyData JupyterLab extension. When you run that, the first thing it does is ask you some questions. It's going to ask you what type of extension do you want. We're going to do a front-end extension. I'll skip over explaining these others to save a little time. It asks you a bunch of questions, the author's name, extension author email, JavaScript package name and Python package name. We're going to use the same name. This template will generate both a JavaScript package and a Python package for your extension, and you can distribute either one or both so that users can simply install them. For example, the Python package, so you can put it on PyPy and the user can simply run pip install to install your extension. Ask for a description on your extension. The next 3 questions, we're going to say no to keep the tutorial simple, but they're important questions. Does the extension have user settings? We can set it up so that users can have different preferences for your extensions. You could set up a binder example, and you can set up regression tests for your extension. And finally, it asks you for a URL for your extension. It'll list through all the files it's creating. Let's take a quick look at those files. So it created a directory with the name of our extension, PyDJLX. And notice inside that directory, there's another directory with the same name. We'll talk about that in a minute. But it's got the basic package files in here, a changelog, a license file, a README. I want to focus on a couple of files in here first before we go further into the tutorial. First one here is the package.json file. This is a file of JSON that defines the package for the packaging manager. If you look inside of it, you have the name, the description, some keywords, a home page, file types that are allowed in this package. I want to focus on one particular section of this file first, and that's this script section. So the packaging manager, JLPM, has a command called run. You say JLPM space run, and then you can run any of the scripts that are defined in this package. We're going to be running this script a lot, the build script. This is actually 2 scripts. First is JLPM build lib, which is another script down here. So you see these scripts can call each other from within the file. This is just going to do a TypeScript compile with a source map for debugging purposes. Then we'll do JLPM build lab extension dev, which is down here, and that's just going to call Jupyter's lab extension command with the build command with a development flag set. So you can read through these. There's a lot of other useful scripts in here. The other section of this file I'm going to focus on here is the dependencies section. Right now, this do nothing template is only dependent on the @JupyterLab application itself, and we'll see later how we can add other dependencies here. Here's the subdirectory PyDJLX I mentioned before. This directory is empty when you first create this template. When you build your package, this is where it's going to get put, and this is what gets distributed, this directory. You'll notice there's a source code directory here with source code file index.ts. And if you look at that, you see it's small, 18 lines. This is your extension, your do nothing extension. So we're going to import Jupyter front end. This is the Jupyter application itself. We'll import Jupyter front end plugin. This is the plugin class we're going to use to define our extension. And both of those come from @JupyterLab application package. Now here's our extension right here. We're going to declare a variable. I'm going to call it plugin of type Jupyter front end plugin. And I'm going to set some properties on it. We're going to set an identifier. This is just a string. There is a convention within JupyterLab to put a colon in identifier strings so that on the left side you kind of have a scope and on the right side something more specific. That's just a convention. We'll give it a description. Autostart equals true means when the user starts JupyterLab, I want my extension also to start. And how does that happen? Well, the Jupyter front end will call my activate function that I'm defining here. Right now it's an anonymous function receiving a variable called app of type Jupyter front end. So the Jupyter Lab is passing the Jupyter front end itself into my activate function so that I can interact with it. But this do nothing template is not yet interacting with it. All it's doing is writing to console.log, Jupyter Lab extension, PyDJLX is activated. And finally, we export the plugin so that the rest of JupyterLab can see it. At this point, if you want to create a Git repository out of your package, you can do that. I'll give you the link to my repository at the end. What I did was I created a commit for each step in the tutorial. So we'll be looking at the diffs, the commit diffs, to see the code changes at each step in the tutorial. This is just to show you that the template also created a bunch of hidden files, including a git ignore file for you and stuff like that. So now we want to build our project. Before we can build our project for the first time, we have to install the dependencies. So we're going to run the packaging manager, JLPM install command. Again, this installs the dependencies of our package. It's not installing the package itself. So when you run that, this part of the screen here will repaint several times over as it's resolving all the dependencies. Mine took about 20 seconds to run. And when you're all done, you'll see two new files in your directory. Yarn.lock is just a text file. You don't need to worry about it. It lists all the interdependencies between the various packages. And the note underbar modules directory contains all the packages that you just installed. Let's take a look in there. This is just the first top 18 package scopes that are in there. You can see here's @Jupyter, @JupyterLab, and @Lumino. We'll be using these package scopes. I got some 436 package scopes installed. This number might vary over time as the packages change, but it should be close to that. And if we look inside one of them, this is looking inside the @JupyterLab package scope. There's 16 packages that got installed. Here's @JupyterLab application, which we saw already, and we'll also be using @JupyterLab app-utils. So now we can build our project. We run JLPM run build. This is one of those scripts in the project.json file we saw. And when you run the build, the screen looks something like this. It should say successful at the bottom. And now that it's built, now we need to install our extension. Before we install it, we can run Jupyter's lab extension command with a subcommand of list to list the extensions that are already installed. And it will also tell us where it's installed, and we can ls that directory and see it. Then we would install it. We could install it with pip install. The problem with this is if we use pip install, then every time we make a code change, we have to reinstall it again. So instead, we're going to install it with lab extension develop. -- overwrite means anything that's already installed to overwrite it. And that way, every time we make a code change, we won't have to reinstall it. And then we'll run the list again to see it. So here's running the list the first time. We see there is one extension already installed. JupyterLab Pigments comes with JupyterLab. And it also tells me where it found it. It looks in several different places to find extensions. And if I ls that area, I can see that directory. This is analogous to the PyDJLX subdirectory that we saw before that. I said the package would be built in that directory and distributed that way. So now we're going to run the develop overwrite command. That's up here. It tells me that it's installing, and it tells me it's symlinking. Now if I run the list, I see I have 2 extensions installed, including the one we just created. And if I ls, you can see that my extension is installed with a symlink back to the directory where we're writing code. So now we change our code, it's automatically in place. So now we need to test it. So we want to run JupyterLab. I recommend running it in a different window. So you're coding in one window, running in another. Don't forget to activate your conda environment in the other window so that it's looking at the same stuff. And when you run it, it looks like this. Where's the extension? Where'd it go? Well, all the extension is doing right now is it's writing to the console. So I'm running Chrome here. So if you go into Chrome and you come down to Developer Tools, you can open up the console. And there in the console it says JupyterLab extension PyDGLX is activated. So you can see it's working. But it's not doing anything. So all that was step 0. That's the biggest, longest step in the whole process. So now we're going to create a command in the command registry to actually do something. And the rest of the tutorial is just we're going to change the code a little bit. We run JLPM run build, and then we're going to refresh the browser to pull the code into the browser. So here's the code change for adding a command. We were just writing to the console, but now we're going to specify a command ID, just a string. Now we're interacting with the application. We're going to, on the command registry, app.commands.addCommand, and we're going to give our, pass in the command ID and specify a label, hello world, and this is the key to the command registry. We're going to, we give it a command ID and an execute function. We're going to tell it to execute a function, say hello. Down here we have say hello, and right now say hello is just going to say hello world to the console. This is unusual. We're going to execute the command right from inside the activate function. We're just doing that for testing purposes. Run the build, refresh the browser. There's the build. And here's refreshing the browser. Now when I refresh the browser, not only do I get that it's activated, I see my hello world in the console. So now let's see how we can execute this command from the command palette. We have to do a few more changes here. So we're going to import iCommand palette from @JupyterLab apputils. And we're going to add a property to our plugin, a requires property. This is just a list of these tokens, these services that we require to be passed into our activate function. So we're going to say we require the command palette. So now the JupyterLab function will pass not only itself, but the command palette into our activate function. The top part of our activate function where we add the command to the command registry remains the same, but now we're going to call palette.addItem, pass in the command ID, that's all we need. The command palette knows how to access the command registry and call the execute function. And we're going to give it a category of anything because the categories are alphabetical on the command palette, so I want it to show up near the top. Run the build, refresh the browser, there's the build here, and now when I refresh the browser, it disappears from here because we're no longer doing it in the activate function, but now I have hello world over here in the command palette, and when I click there, now it shows up in the console. Okay, so now let's modify our extension to actually do something useful. I'm going to create a widget on the screen. This is the main area here, again, just to refresh your memory. When you see my code in the repository, I'm going to skip step 3A. All I did was break out the activate function. Anonymous functions are great when they're small, but it's starting to get kind of big, so I broke it out. But we're going to look at step 3B, where we create a main area widget. Let's see, taking a little closer look at the code. So now we're going to import widget from @Lumidrome widgets. We're going to import main area widget from @JupyterLab apputils. We'll see what we're going to do that in a second. So here's the widget we're going to create. We're going to declare a class hello world widget, extends widget. All we have to do at this point is create a constructor for our widget. We're going to call the super to instantiate the parent and set a few variables. We're going to set an ID. Hello world, this.title.label, we'll give it a label in the title bar, hello world. This.title.closable equals true means that the user will be able to click the X in the title bar and close our widget if they want. And then I'm just going to declare some HTML elements. I'll call document.createElement, create a body, create a heading, set the heading inner text to hello world from PyData. And then we'll use a pen child to attach the heading to the body, and then a pen child to attach the body to this.node. This.node is my widget itself. So after that, we're going to modify our say hello function. It's no longer just writing to the console. We're going to instantiate a hello world widget, put it in a variable called content, and we instantiate a main area widget, passing in our widget as the content. So we'll get all the properties of main area widgets where you could drag them around on the screen and all that stuff and our widget will be inside it. Now we also have to pass in the Jupyter front-end application because we have to interact with another part of the application. We saw the command registry before it. Now there's a part called the shell, which holds all the widgets together. So we're going to call app.shell.add, pass in our widget, and we're going to say we want to pass it into the main area. You can say here left, right, top, bottom. There's a couple of different things in the documentation where you can put your widget. Then we activate the widget by ID. And now, since we're passing that into hello world, the execute function in the command registry only takes a certain type of variable, and we'll see what that is later. So the best way to get the application in there is I'm changing the execute function to an anonymous function that simply calls hello world, calls say hello with the app passed in. So run the build, refresh the browser, and now when we click on hello world, we get a nice little widget over here, hello from PyData. I can move this over to the side, I can move it down to the bottom, I can click it again and get a second one. Now we have a widget on the screen. Now let's see how we can style the widget. The directory that was created before has a style subdirectory, and in that there's a file called base.css. There's just a comment in there for now. We're going to style the body, give it a background color, a full height, style the header. Position it about a third of the way down and stretch it back and forth from the top. Notice that we're styling it only for a certain CSS class, HWW. I made this up for Hello World widget. If we didn't do this, we would end up styling all of JupyterLab, and we don't want to do that. We only want to style our widget. So now we have to go back into the constructor for our widget, and we'll call this.add class and pass in HWW so that it has that CSS class associated with it. Run the build, refresh the browser. And now, instead of this boring little gray widget, we get a nice, colorful hello world from PyData. All right, so now let's see how we can execute the command from the launcher. Again, this is the launcher over here. We're going to put it in the notebook section because that's near the top. So we're going to import iLauncher from @JupyterLab launcher. And now down here where it says requires, I could say iCommandPalette, iLauncher, and I would get it passed in. But suppose I want my extension to work even if the launcher was disabled. The launcher itself is an extension, and users could disable it or not install it. So there's another thing called optional where I can say, I also want this passed in if it's available, but if not, I'll continue to run fine. So now, my activate function accepts the command palette, and it also accepts the launcher as iLauncher or null if it's not available. Down here, we're going to call launcher.add, similar to when we called palette.add item. Pass in the command ID, specify a category of notebook, so it's near the top. And notice, though, I have to wrap this in an if iLauncher because maybe the launcher is not there. If it's not there, I'm just going to write to console.log, iLauncher is not available. So now we're going to run the build, refresh the browser, and when we run the build, we get an error. What's the error? Can't find the module at JupyterLab launcher. So the module should be here in the JupyterLab package. This is alphabetical. It should be between docResidency and MB format, and I don't see it there. It didn't get installed. It wasn't one of my original dependencies. So in order to add a package that you're newly dependent on, you call the packaging manager add command to add that package. And when you do that, it looks a little like the original install. And now I see the launcher is in the subdirectory where my packages are. Notice, however, if I run git status, my package.json file has changed. So what happened there? The dependency section added the new dependency. So to summarize, JLPM add does two things. It installs the package in the node modules directory, and it also automatically edits the dependencies section of the packages.json file for you. So now I can run the build, refresh the browser, and now I have my hello world icon here in the middle of the launcher. I can click that, hello from PyData, and I can click this, I get hello world from PyData. Now suppose I want to execute it with arguments. Maybe I want it to behave differently from the two different places that I'm launching it. So again, I mentioned that the execute function only takes one type of argument. That is, it has to be a constant JSON object. So I'm going to accept it here as args, and pass it in to say hello. And down here, where I'm adding it to the command palette, I'm going to add arguments with a key of greeting and a value of hello from the command palette. Now I could do the same thing down here with the launcher. I could say hello from the launcher, but what I want you to see is what happens if I have arguments and what happens if I don't have arguments. So down here, functions say hello, it's now going to receive the arguments, and it's going to take the greeting attribute of the arguments and pass it into the hello world widget. If there are no arguments, this becomes null. And if there are arguments and there is no greeting, it is also null. So my constructor now accepts a greeting as either a string or a null. If it has a greeting, it's going to set the inner text to that greeting. If not, it's going to set to the default hello world from PyData. Run the build, refresh the browser, and now when I click from the launcher, I get the default hello world from PyData, but when I click from the command palette, I get hello world from the command palette. And finally, to create a sidebar widget, I'm going to skip over most of this. Most of this part is not JupyterLab specific. It's just continuing the code. This is what the sidebar widget looks like, very similar to the other one. We set various things. I'm going to create the buttons. I'm doing a different class because I want to style it differently. And here where I instantiated at the bottom of the activate function, notice when I'm calling app.shell.add, I'm saying left. I want it to go on the left side. Run the build, refresh the browser, and now here's my sidebar widget. Notice though, JupyterLab remembered that the command palette was open, so I have to actually click here to open up my sidebar. Sidebar looks kind of small though, over here with my buttons. You saw styling before, so I'll skip over that. We made some big buttons. Now, to add event listeners, I just created a mapping between the buttons and hello world in different languages. I loop through them, I create a button, event listener, and in the event listener, again, I'm calling the execute function from the command registry to execute the command ID, with the greeting from this mapping. And I now need to pass the app and the command ID now into the sidebar hello world widget. Run the build, refresh the browser, and now when I click on each of these buttons, I get hello world in a different language. And that's basically the end of the tutorial. At this point, if I had a lot more time, I'd go into the documentation a bit more, but I'll give you the link to these slides and the repository, and we saw the AI command palette. These are all the various tokens. There's some 82 different useful services that you can use when you're building your own extensions. Other useful links here on the slide deck, which you'll have access to. If you remember anything, this is the address of the repository that contains these slides and the code and the instructions for the tutorial. So, thank you.